Hey, it's Mr. Lum. Today we're going to be looking into chemistry and doing some definitions that surround chemistry. So let's start. The first definition that we have is element. What is an element? It is a pure substance. An element can be found on the periodic table. You may have seen a periodic table. They look like this. So here's a periodic table. It has all of the elements on it. These are all things that cannot be broken down any further and still maintaining their properties. So there are many elements on here. Now, a compound is a substance that is made of two or more atoms or two or more elements. Okay, so if you have two elements and they're combined together and they formed a bond, and we'll talk about bonds later, they will make a compound. Now, an atom is the smallest particle an element can be broken down to. One particle of an element is called an atom. So let's do an example maybe. So here's our example, H2O. We can find H2O on our periodic table. Here is H, or in other words, hydrogen. Here is O, in other words, oxygen. Now, H2O is more commonly known as water, and it looks kind of like this. You have a particle like this that is oxygen, and you have another particle that is like this, that is hydrogen, and another one that is also hydrogen. Okay, there are two hydrogens, that's why we give this subscript 2, and one oxygen. If there's only one, we don't bother writing a subscript right there. So here's H2O. Now H2O is made of 3 atoms. So right in here there are 3 atoms. There are 2 hydrogen atoms, 2 hydrogen, and those are the blue ones, and 1 oxygen. There are 2 elements here. Okay, so there's 2 elements. And all of this together makes one compound. Okay, so we've used a bunch of our definitions already. There are 3 atoms. Okay, the smallest particle an element can be. And the 3 atoms are 2 hydrogen and 1 oxygen. There are 2 different elements, hydrogen element and an oxygen element. And all of these things put together makes one compound. Okay, so those are our 3 new vocabulary words: element, compound, and atom. Now let's take another look at another definition called chemical change. A chemical change is when a compound changes the way the atoms are arranged. So what we have here is we have NaOH, NaOH, so this is sodium, oxygen, and hydrogen, and it makes sodium hydroxide. And this is HCl, hydrogen and chlorine. Together it makes hydrochloric acid. Now, when these react together, what is going to happen is these atoms are going to change and be in a different arrangement. So let's take a look at the different arrangement when they change. So they change into NaCl and H2O. Okay, and so which is a different arrangement than what we had at the beginning. And the particles are also going to change. Now we can see that it's H2O, which is right here, and NaCl. This is a chemical change. It is different from what is called a physical change. In a physical change, the change that affects the form or phase, but not the chemical composition. So what we have here is H2O solid changing into H2O liquid. So in other words, what we have is we have ice changing into water. So here's our piece of ice. Ice is a solid. And what we can see is that all of these H2O particles are all tightly packed together in a solid structure. Now what happens if heat is added? It's going to change into a liquid. And what we can see is that now the H2O is a liquid, and all that has happened is that the compound or the particles in here have started to move around. Okay, and this is a physical change because the atoms in the compound have not moved. They're still H2O. Now there's things called subatomic particles. In an atom, there are particles that are smaller, and every atom is made up of 3 types of subatomic particles: protons, neutrons, and electrons. Protons have a positive charge, neutrons have a neutral or no charge, and electrons have a negative charge. So here is a picture of an atom, and what we can see the 3 types of particles. We can see protons right here. Here are protons, and they have a positive charge. That's why we can see the plus. We have neutrons right here. And they have no charge. That's why there's nothing written on them. And then we have electrons right there. They have a negative charge, and if you look closely, you can see a little minus sign right there for the negative charge. So let's fill in this table that we have here. There's 3 types of subatomic particles: protons, neutrons, and electrons. The symbol for the subatomic particles are P, N, and E. The location of these particles are, well, as we can see, protons here are in the middle, so the location is in the middle. Neutrons are also in the middle, so where they're located is also in the middle. Now, in the middle, we call it the nucleus. Okay, because they're in the middle. Neutrons are also located in the nucleus, in the middle. Now electrons, they are outside. They're surrounding the nucleus. As we can see, they're not in the middle, so they are surrounding the nucleus. Now, the charge of protons, as we can see here, is positive, and the charge for electrons is negative, and the charge for neutrons, there is no charge. So we can just write 0. Now, mass. As we can see, protons and neutrons are almost the same size, but electrons are very, very, very small. And that is also true with the mass of these subatomic particles. The mass of a proton in comparison to an electron, a proton is much, much larger. In fact, if an electron was given a mass of 1, so a relative mass of 1, a proton's mass will be 1,836. And a neutron's mass would be 1,837. A proton and neutron almost have the exact same mass, but an electron is much, much smaller. It's almost, in comparison to a proton and a neutron, 0. Okay, very insignificant.